Okay, I think we'll get started. Good morning, everybody. John Holland, Chief Development Officer of Pinchin speaking from Richmond, BC. Welcome to today's webinar on funding opportunities for energy and greenhouse gas reduction. This is part of a practice innovation series that we put on where we share our lessons with our community and encourage you to be involved and make suggestions for further webinars if that's of interest to you. We have three speakers today. Mr. Andrew Burns, Mr. Blake Edwards, and Ms. Tanya Powanicki. So first of all, Andrew Burns is a project manager and mechanical engineer in the mechanical engineering group of Pinchin, and he's responsible for many of our district energy and heat recovery projects. Andrew holds a Master's of Science in Engineering and a Master's Certificate in Project Management. He's a PEng in EGBC and also the American Society of Heating and Refrigeration and Air Conditioning Engineers, ASHRAE. He's worked on several projects for Pinchin, including the Blatchford redevelopment in Edmonton, Marine Gateway in Vancouver, Victoria Commons, the ESS, and the McDonald Island Wastewater Treatment Plant heat recovery project. So welcome, Andrew. He'll be your first speaker. Second speaker is Blake Williams, CEM, who is an SMB energy coach with BC Hydro. Blake's been with conservation and demand management since 2010. He was a graduate of BCIT's first cohort of their Sustainable Energy Manager program in 2009, designed by the Association of Energy Engineers, or designated by, with energy conservation. He's worked with municipalities, electrical contractors, consultants, utilities, distributors, and BC Hydro and a small and medium business energy coach since July 2021, working specifically with CleanBC on energy incentives. For our guest speakers, both Blake and Tanya, we give them the option of being paid or making a contribution to a charity, and Blake has kindly made a donation to the Vancouver Food Bank in lieu of a fee for today's presentation. So thank you for that gracious donation, Blake. And last speaker will be Tanya Powanicki, also works with BC Hydro as an Alliance energy professional supporting industry and customers to navigate through the various incentive programs. Tanya's been involved with BC Hydro's programs for 2 decades, helping advance energy efficiency and energy management, which now includes electrification and greenhouse gas reduction. We all know that. And in lieu of a fee, Tanya has also made a donation, in this case to the United Way, in lieu of a fee for today's presentation. So thank you, Tanya and Blake, for those donations. So we do have a couple of guests with Hydro who will be available to us to answer questions at the end if required to support our 3 speakers. So we look forward to all your participation, your questions, your future guidance, so we can continue to present and improve this series for your benefit. And with that, I'd like to hand the speaker over to my colleague, Andrew Burns. Thank you, Andrew.
Good morning, everybody. Thank you for joining us today. Yeah, as John mentioned, I'm a mechanical engineer here at Pinchin, and my passion is in building energy efficiency, both for individual buildings and community scale systems, trying to find smarter ways to heat and cool buildings more efficiently. If you go to the next slide. And the reason for this is that buildings make up one of the largest contributors to greenhouse gas emissions in Canada. As many of you probably are aware, buildings are the 3rd largest contributor to greenhouse gas emissions, besides behind only transportation and oil and gas industry in Canada. So one of the most substantial contributors, and one that we can do something about, fortunately. Next slide. When it comes to those emissions emitted by buildings, the largest 2 contributors are space heating and domestic water heating, contributing, nearly all of the emissions associated with buildings in Canada, both for residential, as shown on the left, and commercial buildings, as shown on the right. Biggest contributors: space heating and domestic hot water heating. Next slide. And but the solution to this problem is quite clear in industry. It's a solution of electrification. It's a solution of using heat pumps to heat and cool buildings instead of combusting fuels like natural gas or propane or oil. Combustion, of course, releases carbon emissions into the atmosphere, while heat pumps are non-combustion ways of heating and cooling buildings. They actually, heat pumps operate by moving heat from areas of low concentration to areas of high concentration. So no burning of fuels needed to heat buildings. We use heat pumps and clean electricity to move heat. Next slide. And the reason for this is quite clear. The benefits come from having a very clean electricity grid in Canada. All across the country, in most provinces, electricity is generated very cleanly through hydroelectricity. We have very low carbon intensity for grid electricity in BC. So fuel switching from fuel oil or natural gas onto electrically driven heating system brings a significant reduction in greenhouse gas emissions because of the cleanliness of the electricity that's being used to do the heating. Some of the best provinces across Canada for this, BC is one of the best, Quebec as well. Manitoba has very low carbon intensity. But we're going to focus, of course, on programs and reasons for doing this in BC. Next slide. So let's just discuss briefly how a heat pump operates. For those who may not be familiar, a heat pump uses a refrigeration cycle to move heat from areas of cold to areas of hot temperature. It's not a combustion-based way of heating, as I mentioned. It's using a refrigeration cycle, which is depicted here on the screen. So the first step is you have a compressor that takes a refrigerant gas, compresses it using electricity to compress the gas. As the gas is compressed, it gets heated up as temperature rises, and you can reject the heat into a building or into another medium like water or something where it can be used for doing useful heating. The refrigerant, after it loses its heat, then goes through an expansion valve where its pressure is reduced, and as it expands, it cools. And now it's a very cold refrigerant gas, and it can be used to pick up heat from some sort of energy sink or energy source, like the atmosphere or the ground or from a fluid. So we use a refrigeration cycle. A small amount of electricity drives this cycle and pushes heat from an area of cold to an area of hot, much like your refrigerator or something in your house or running an air conditioner in reverse. The cooling is rejected outside, and the heating is rejected inside where it's needed. Next slide. Now, there's a number of heat pump options. They come in all shapes and sizes. There are air source heat pumps, water source heat pumps, air-to-air heat pumps, air-to-water heat pumps, water-to-air heat pumps, all different kinds of configurations, but they always have the same refrigeration cycle being used to drive heat from a cold side over to the hot side. An air source heat, excuse me, any kind of heat pump needs to be coupled with an energy source that provides the low-grade energy that's needed. This could be like a Geoexchange system is one example. Air source heat pumps are a common example where they pull the heat out of the air, concentrate it, and move it into the building. You know, there are other sources as well for of low-grade thermal energy that can be really effective with heat pumps. One example is wastewater heat recovery, something we've been involved with a couple of times, where you have a very high and regular flow rate of wastewater from a site or from a community. It's fairly warm wastewater because of all the showers and the hot water going down the drain. So it's a valuable resource, in fact. And using a heat pump, you can extract all that heat and use it for useful purposes. And another example is just on-site energy recovery. Heat pumps can be used to recover energy within a building. If there's air conditioning going on one side, heating going on the other, heat pump is a perfect kind of solution because it produces both the cold and the hot side. The cold can be used for the air conditioning load. The hot side can be used for the heating loads. And it's a very efficient way of moving heat around within a building. Next slide. So there's, heat pumps have a number of advantages. One especially of growing importance is economic advantage compared to natural gas or other fossil fuel based heating options. When we talk about combustion-based fuel heating, we're often talking about natural gas in BC. It's very prevalent, but it's an increasingly expensive option. This chart depicts the forecasted natural gas prices and the impact of rising carbon taxes. And a lot of people think of natural gas as being very cheap, and it is right now. It's, the global supply of natural gas is high, especially in North America. Gas prices are very low. So it is a fairly inexpensive fuel option. But, carbon taxes have come into play and are scheduled to increase over the next decade. We're currently sitting at a carbon tax of $40 a ton, which adds around 2 gigajoules, $2 a gigajoule to the price of natural gas. But over the next 10 years, according to the federal plan, that carbon tax is scheduled to increase from $40 a ton up to $170 a ton. By the time we get to $170 a ton, it'll be adding $10 a gigajoule to the price of natural gas. So we can expect to see increasing costs of natural gas options over the next decade. And heat pumps, because they're driven by electricity, which is very cleanly generated in BC, not subject to the carbon tax. So it's a way to avoid the risk of the increasing cost of natural gas and the increasing pricing of carbon tax on that kind of fuel. Next slide. Here's just a quick example for a hypothetical scenario comparing the operation of a heat pump to a gas boiler when you're looking at heating a building. Let's consider, for example, a 125,000 square foot building built to step 3 of the BC step code, so fairly efficient building. Although this example could be applied to any kind of building. If you look at the options of heating with a gas boiler on the top versus heating with a heat pump on the bottom, let's say in both cases we have 1,000 megawatt hour annual heating load. A gas boiler uses a little bit more gas, 1,050 megawatt hours of natural gas, let's say, whereas a heat pump, which operates with a COP of 4, which is an efficiency of 400%, to produce that same 1,000 megawatt hours of heating would use only 250 megawatt hours of electricity. So substantially less fuel input with using a heat pump, because the heat pump, again, is using a small amount of electricity to move heat from an area of cold to an area of hot. The emissions between these two options there's a striking difference. Natural gas, you'd emit with a natural gas boiler, you'd emit 190 tons of CO2. A heat pump doing the same amount of heating would emit only 3 tons of CO2. So it's a 98% reduction in greenhouse gas emissions just by using a heat pump instead of a gas boiler for heating. And then the fuel cost is important to look at as well. And there's 2 columns presented here. One is fuel cost today, one is fuel cost in 2030. If we look in today's dollars, around $38,000 for the cost of gas, based on $8 a gigajoule and $40 a ton carbon tax. That compares with around $30,000 worth of electricity. So, in the same ballpark, slightly more cost effective to use the heat pump in this particular case, although it depends a lot on particulars of the individual site. But look what happens 10 years from now. Once carbon taxes come into play, the full $170 a ton, they add substantially to the cost of heating with a natural gas boiler option. Now we're up to $66,000 a year for heating with a gas boiler compared to $35,000 a year heating with a heat pump. So it's a savings of almost 50% in the future. So this is the economic advantage of heat pumps. Today they make a little bit of sense, but as carbon taxes come in, gas prices are going higher. There's a substantial savings that can be achieved using heat pumps. So why not build today for what we think is going to be making economic sense now and even more economic sense in the future? Next slide. There's besides the environmental and economic advantages of heat pumps, using heat pumps or low carbon heating options, electrified heating options can help with regulatory compliance for new projects as well. Here's an example. It's just one example. This is City of Vancouver's zero emission building plan. This is for new buildings. They have stepped targets for greenhouse gas emissions intensities, starting from a 2007 baseline and trying to drive towards net zero emissions by year 2030. So new projects that are getting started or major retrofits of existing buildings are going to have to comply in the City of Vancouver, are going to have to comply with these targets, which means not only is it make environmental and economic sense to look at heat pumps, but in many cases, it's a requirement of rezoning, or it's a requirement of getting a building permit, is going to be to integrate these low carbon heating options within new or existing buildings. Next slide. Fortunately, it's not really that much of a pivot to use a heat pump for heating a building compared to the old way of doing things, using a gas boiler and heat pump, or chiller, cooling tower kind of configuration for heating and cooling a building. On the left is a building that uses a gas boiler in the basement, cooling tower on the roof. Gas is the fuel use going in. It's not substantially different to heat and cool the same building with a heat pump, which is shown on the right. Maybe a rooftop mounted air source heat pump that pulls heat out of the air in the wintertime and provides heating into the same hydronic system in the building, and runs in reverse in the summertime, providing chilled water into the building's hydronic system and sending the heat out into the air, much the same way that a cooling tower would. So, heat pump can be substituted in many cases for a gas boiler very effectively. So how do you know if a heat pump type heating system would be the right step for you? The first step is usually to conduct an energy study, or an energy audit, it's called, if it's an existing building. And there's kind of 3 steps to this. The first step in an energy audit or energy study would be to investigate the site, doing energy modeling or looking at energy bills, seeing how much, where the fuel use is going in the buildings, how much natural gas is being used, how much electricity is being used, reviewing drawings and reports, reviewing the plans for the building. If it's an existing building, we would do a walkthrough, meet with building operators, and discuss kind of what the current issues are. And I try and identify options for integrating heat pumps within an existing building or a new building. Then we take it away. As part of the study, we do some analysis, we do some energy modeling, we do some scenarios. What if we did a heat pump of this size? What if we did a heat pump of that size? What would the energy and carbon savings be? And how much would it cost? And how much would it save, right? That is one of the biggest questions to be answered in that financial analysis. Finally, there's the reporting, making a recommendation for a bundle of energy conservation measures, or an a low carbon energy concept for the site if it's not an existing building but a new building, and providing recommendations. Part of my job as an engineer is to work with clients and identify solutions that meet not only environmental and regulatory requirements, but meet the needs of the customer, right? Many of the projects we've been involved with, which I'll speak to in a minute, some of the most successful ones, in fact, are those that kind of scratch 2 itches at the same time, right? You putting in a heat pump to help reduce greenhouse gas emissions for one, but maybe also increasing the availability of cooling in a certain space, or replacing aging equipment with new equipment. That's kind of the ideal scenario that we'll speak more about in a moment. But when you can find a low carbon electrified solution that solves a couple of problems, that's when it really starts to have exponentially more benefit and make more sense for a particular project. Next slide. So we'll talk about funding options now. I've explained hopefully clearly enough the why of why heat pumps make sense in BC, why we're investigating them, why they're becoming more and more a requirement of new buildings and existing buildings. And there's a number of funding options available to help support these initiatives at the moment. The province, of course, is very much on board with the drive to electrify and the drive to reduce carbon emissions from buildings provincially. And that's manifested in the CleanBC program. And we're lucky to have a few members of representatives from BC Hydro who are administering the CleanBC program here, and they'll speak more about that in a moment. CleanBC, this program is largely about fuel switching and electrification. So if you're converting from a natural gas project or existing natural gas system onto a heat pump option, the CleanBC program is a great fit. But there's also FortisBC funding available. They have a custom performance program that it helps with inducements for energy studies, and capital contributions towards projects that reduce natural gas emissions. And in some cases, that includes, heat pump, heat recovery chillers, and so forth for buildings. So both of these are available options, but today we're going to talk more about the CleanBC program. And so with that, I'll turn it over to Blake.
Thank you, Andrew. Hi, everyone. Good morning. My name is Blake Williams. I'm a small, medium business energy coach, and I work at the Ministry of Energy, Mines, and Low Carbon Innovation, and we work with BC Hydro. Next slide. So CleanBC, for those of you who don't know or might have heard it before, it was released in 2018, and it more or less is government's strategy on how to achieve and maintain the targets for greenhouse gas reductions out to 2030. Just recently released was the government's roadmap to 2030. It was just released a couple weeks ago, and it has electrification as its core for achieving these targets. Next slide. CleanBC has 5 pillars. I'll be discussing the one on the left, better buildings. As the name would indicate, it has to do with buildings. Next slide. The offers in the Better Buildings portfolio are listed on the screen, one of which is for new construction. The other 3 are for retrofit. And I'll be breaking down each one throughout the presentation. Next slide, please. So all 4 of these, they all, as Andrew had mentioned, they all pertain to fuel switching. That's going from natural gas or any other fossil fuel for that matter to clean electricity. So there has to be in every project, regardless of which one, has to demonstrate a GHG decrease as well as a load increase on the grid. Also speaking to what Andrew had mentioned, a lot of these electrification measures pertain to space heating, water heating, and ventilation as well. Next slide, please. So the kind of projects we're looking for are typically found in buildings with significant year-round cooling needs. These would be hospitals, shopping malls, large data centers, and the like. Also buildings that have 100% outdoor air ventilation systems, where you're constantly having to condition outside air. Then also we're looking for opportunities where there's a significant service hot water loads. This would be typically found in hotels, restaurants, and MURBs, and also hospitals as well. Buildings also with centralized exhaust ventilation systems, and buildings also with a lot of waste heat, where they're rejecting a lot of heat, such as arenas and food stores. Next slide. So much like Andrew had mentioned, there's a lot of different, air to air, air to water, water to air. As you can see on the screen, it's got it all. Where the check marks are, you see a lot of it where it covers space heating opportunities as well as domestic hot water. Next slide. And next slide. So the first program I'm going to talk about is the commercial new construction. It's a program that it requires a minimum of 400 tons per project, and this is a lifetime savings. So if the service life of a particular equipment is 15 or 20 years, it's going to be an annual reduction, and this would be based on the modeled baseline compared to what the electrification model would provide. So there is a requirement for studies, energy study funding. So funding is available for those energy studies up to $15,000. The capital for the commercial new construction is capped at $500,000. And there is also a 10% bonus for any project that is 100% electrified. And the rate of instruction, that's good. Next slide, yeah. The rate of incentivization depends on what you're building over and above the building code. So as you can see on the screen, just looking at retail, for example, the rate of incentive for every ton of CO2 avoided, just by, say, meeting the BC building code would be at 30. That's on the low end. And on the higher end, where you're going above and beyond, is step 3, where you see a TEDI and a GHG intensity of less than 4 kilograms of CO2 equivalent per meter squared. So you can click to the next slide, please. And then there's some examples also for MURBs. And you can see how hitting a higher performance is going to net you, or your customers rather, a higher incentive per ton avoided. Next slide. Next slide. So the next 3 are going to be the next 3 programs are going to be the retrofit. The first one up is the custom program. The custom program, there we go. It was released in 2018. And this is for the larger of the programs. This is for anything that hits 1,200 tons of CO2 equivalent or greater over its lifetime. It too requires study funding, an energy study, and the funding for it is up to $20,000. There's also a cap on that, 50%. And then there's also on the capital side, it is capped at $200,000. And it is based on a rate between 40 and 60 tons per CO2 equivalent. The deadline for these, so once a custom application has been approved, the applicant has up to 18 months to commence and complete the project. And on the energy study, it's 6 months. Next slide. For the not so large projects, we have custom light. It is between 500 tons and 1,200 tons of CO2 equivalent. It too has an energy study requirement, and its funding, because it's not as robust or comprehensive as of an energy study, the study funding is only up to $2,000. The capital incentive is up to $72,000. Pardon me for my dog barking. And it is also based on the same rate of incentive between 40 and 60 tons CO2 equivalent. Because the projects are not as elaborate as some of the custom ones, the deadline for completion is 12 months. Next slide. The newest addition to the CleanBC portfolio is Commercial Express. And Commercial Express was released, about a year ago next month. And it's a much simplified version of Commercial Light. Unlike the other 3, it doesn't require an energy study, and there's no minimum threshold to be eligible. However, it has 7 different building types that are currently in the program. And there are specific and defined electrification measures for each type of building. The Commercial Express has a cap of 100,000, so it's a slightly more generous program than Custom Light. However, because it is so prescriptive in nature and very easy to get off the ground, it has a 9-month date of expected completion. Next step, or next slide. As I mentioned, because it's very easy to get approved and get off the ground, there are between 7 and 10 questions that need to be filled in for an application to at least be considered. The 10 questions are on the page right now. You can see it's just really basic information. We're not needing engineering data or anything like that. You know, roughly where it is, building type, just for me to be able to provide you with a ballpark of incentivization. And then once it is submitted, it goes through all the proper procedures and then gets, then you get your approval. Next slide, please. So here are the 7 building types that are currently in the program. We have small offices, strip mall, restaurant and food services, warehouses, MURBs, school gymnasiums, as well as large retail. That would be your big box stores. Next slide. And so diving down a little into what are the approved or included in electrification measures under Commercial Express. It does depend on the building type. So you're going to see a lot of repeats, but then in certain building types, you're going to see some new offers that aren't in others. And so you'll see, typically I see office, I also see retail, large retail, and warehouse. Next slide. So both on this one and the previous one, you see a lot of them are to do with rooftop units, whether they be makeup air or mixed air units with electric or gas backups. There's also an electrification measure for restaurants that allows for CO2 heat pumps for water heating. And yeah, thank you. And then there's an overview of the 3 retrofit programs and their respective requirements or thresholds to be met, as well as caps on their funding. Next slide. Perfect. And that's how you can reach me. You can also reach out to, or have your clients reach out to their key account managers at BC Hydro. They're apprised of these programs and offers as well. But of course, you can always reach out to myself at smallbuildings@betterbuildingsbc.ca. And with that, I'll hand it over to Tanya.
Good morning, everyone. Thanks for joining us this morning. So I'll talk a little bit about how the CleanBC programs are operated through BC Hydro and how the BC Hydro Alliance of Energy Professionals is involved. Next. So what is the Alliance? The Alliance of Energy Professionals is really just a network of industry professionals, so consulting engineers, installation contractors, distributors, suppliers, and manufacturers who can help facilitate energy efficiency and these CleanBC projects. Next. So engineering firms such as Pynchon here, who we're partnering with today, are able to support customer applications for the various program offers. And for CleanBC specifically, we keep them up to date on the requirements of the program, which is including the appropriate workbooks that need to be completed. They're able to complete the energy studies and partner with firms to do the energy modeling if they don't do the modeling themselves. And they're also able to help support the implementation of the applicable measures that are being applied for. Next. So the CleanBC Custom and Custom Light offers, as I say, require an engineering firm. So firms that employ engineering consultants that are registered with EGBC. That's the agency that looks after the engineers within BC. And they complete the studies that are going to help support the GHG savings calculations that are provided in the workbooks. And as I say, in the new construction program also requires that the engineering lead and the energy modeler be registered as well. Next. So I'll talk a little bit about some of BC Hydro's other programs as well. So BC Hydro's key account customers, potentially yourselves, can be engaged in strategic energy management program offers, and with that would be able to qualify for co-funding of energy studies, up to 50% of those costs, to help identify energy efficiency opportunities in your buildings, as well as fund project implementation projects to install energy efficient technologies. Next. Other customers are also able to apply for our business energy saving incentives program. And this is a prescriptive retrofit program to install qualifying products with qualified technologies as well. And this is an online application and is supported by registered contractors and distributors. Next. Some of the other programs that BC Hydro partners and operates is the electric vehicle program. And some of you may be familiar with the EV charger rebates for your homes, but there's also programs available for workplaces as well. For the workplace rebates, it is limited to employee parking only and does require the installation of network charging stations linked to a central system. And some other programs that are in development, and again, these tie back into the greenhouse gas initiatives, is looking at some incentives or rebates to convert corporate fleets to become electric vehicle fleets as well. So you'll see more information coming out about those programs shortly. Next. So if you're wondering what program your business might be eligible for, it can be quite confusing, challenging whether to go with an energy efficiency option, a CleanBC program, or debating whether something should be going to CleanBC with BC Hydro or with Fortis. You can always reach out to someone to clarify that. So you can reach out to Pension, of course, to have them help navigate the offers for you, or you can contact BC Hydro directly. If you have a key account manager, definitely reach out to them, or you can reach out to myself or my team as well. Next slide. And here's my contact information if you have any questions at all, whether that's confirming industry, if an industry member is registered, or general questions for BC Hydro. Happy to help. Next, that's it for me. Back to Andrew, I believe.
Yeah, thanks, Tanya. I'll just share a few examples now from projects that we've been involved with to close out this session this morning. This is one that I wanted to share, first of all, that we've are just completing with BCIT in Vancouver. This is their downtown campus, and the situation for them was that they had a growing data center in their downtown campus building, and that was in need of cooling. need of increased cooling capacity to meet the increasing IT load. They had a fairly high cost of energy for heating the building due to the connection to the downtown Vancouver district steam system. And the owner has a strong commitment to reducing greenhouse gas emissions. And the downtown steam being largely natural gas fired is a fairly carbon intensive way of heating. So looking at options for reducing the carbon emissions associated with this building. The solution we came up with was using heat pumps to provide cooling to the data center, chilled water production for cooling in the data center. And as well as producing the chilled water for cooling the data center, they produce high temperature hot water for heating the building. The hot water from the heat pumps gets tied into the building, the existing building hydronic heating loop. We had to use high temperature heat pumps in this case due to the original design of the building, which is designed to use heating water up to 180 degrees Fahrenheit, which is fairly hot and not something that most heat pumps are capable of producing. But we tried to find an innovative way to tie into the high temperature network, high temperature building heating system, and using a high temperature heat pump. This project was the energy study that we completed was funded in part by CleanBC, and as well a capital incentive was provided towards the cost of the project. Next slide. There's another example is of wastewater heat recovery, and this is a growing a technology that's growing in popularity, especially for larger buildings and campus or community type projects, where a centralized wastewater flow from a campus or from a catchment area of a community is all concentrated in one large diameter sewer main. And if you can tie into that main and pull out some of that warm wastewater, it's a great resource for doing heat recovery from. It's a great energy source to power a heat pump to provide heating. This was a project built about 4 or 5 years ago, where it's a 160 unit multifamily development on Cambie Street in Vancouver. Needed to achieve a greenhouse gas intensity target to be compliant with the City of Vancouver rezoning policies. And so the solution was to look at on-site waste heat recovery system. The building happened to require a sump pump or a wet well for collecting the sanitary flows from on-site before ejecting them into the city sewer system. So it provided a great opportunity, having that infrastructure already in place to do heat recovery from the sewage that's in the holding tank. Next slide. Another great system in BC is Geoexchange. We've done a number of projects involving Geoexchange, and Geoexchange, as you may or may not know, involves drilling a borehole down into the ground to around 300 feet deep. You put a pipe down, two pipes down with a U-bend on the bottom, and you circulate an antifreeze solution down through the boreholes, through the pipes. You put it down into the ground cold, and it comes up a little bit warmer. In the summertime, you can reverse the process, and you put the solution down through the piping at a high temperature. It comes back a little cooler. So the Geoexchange system can be used for both heating and cooling. You're basically chilling the big chunk of earth, the big chunk of rock beneath the project site, or heating it up in the summer, cooling it down in the winter. It acts like a big thermal storage battery. Geoexchange has a number of advantages. You know, it's a great energy source with very little maintenance. It's extremely long life because the piping is all plastic and everything is covered underground, and it gives good winter efficiency, especially in areas of the province that are colder climates, where air source heat pumps can suffer from lower efficiency at those very cold temperatures. The disadvantages of a Geoexchange system is the higher upfront capital cost and the space requirement. You need a fairly large land area in order to provide enough boreholes to do the right amount of heat exchange for a project. Next slide. One of the types of projects we've been more and more involved with in BC and across Canada is a district scale approach to heat pumps and energy recovery and energy sharing. This is an example of what we call an ambient temperature district energy system, and it's a way of cost effectively providing this renewable low-grade heat to a variety of buildings within a campus. And each building then can have a heat pump to do heating or cooling as needed from a district energy system, which ties into a centralized Geoexchange or wastewater heat recovery or some sort of centralized renewable energy source. So it's a way of distributing Geoexchange or a renewable energy widely at a district scale. Next slide. And just mentioned there's a number of communities in BC and across Canada that have deployed this kind of approach to widespread adoption, to facilitate widespread adoption of heat pumps. Whistler, BC has one of the first such ambient district energy systems in Canada, but there's also two on the island here in Langford and Saanich, and as well City of Edmonton and City of Halifax are both pursuing similar kind of ambient district energy approaches. Next slide. So what could help you? I mean, we've covered quite a bit of ground here. There's a number of programs available for funding these projects of various sizes. And so I just wanted to share a few thoughts here of what might be something that could help you at your facility. You know, one of the first places to look at taking advantage of this program is doing, when it comes time to do a boiler replacement, replacing old inefficient gas-fired systems with heat pumps. It is kind of one of those sweet spots where you need new equipment anyways, so you're going to have to spend the money. Why not look at something that uses less natural gas, emits less GHG emissions, and provides a business case from the savings that you'll get from avoided natural gas and carbon tax costs. Even if not doing a boiler replacement, heat pump add-on is also something that can be pursued to reduce the carbon emissions associated with existing buildings. In many cases, air to water or air to air heat pump can be integrated within an existing system to provide that low carbon energy and reduce the natural gas use, while you also maintain the existing boiler system as a backup and peaking energy. Next slide. Heat recovery chiller is also a great option, and especially as Blake mentioned, in those buildings where there's a large simultaneous heating and cooling load, strip malls or large MURBs, places that are a mixture of office and residential, or with a high domestic hot water load, are all great candidates for a water-to-water heat recovery chiller that produces usable heating water and usable cooling water at the same time. And then I mentioned already, wastewater heat recovery can be both on-site or off-site recovery from wastewater flows. Next slide. So, and two more, rooftop unit replacements. As Blake mentioned, there's quite a focus at CleanBC. This is one of the most obvious low-hanging fruits, is replacing old gas-fired rooftop units with new ones. No, it's another example of that situation where you're going to have to replace it anyways. Why not use a heat pump, save a little bit of natural gas, and receive an incentive from CleanBC at the same time? Same goes for water heater replacements. Is another good example. A lot of facilities have gas-fired hot water tanks, and there are a number of options for doing hot water heating with a heat pump, either through standalone hybrid hot water heaters or using a heat pump to do preheating of domestic hot water. So lots of options there as well. Next slide. So just in summary, I mean, how does this process all work? I mean, there's three main steps. Identification is the first thing, which is really something that between the owner has to come up with. That's you guys on the call. What is it that you need? What, you know, is it what could help you? So identifying these projects is the first step. Could be for institutional or residential or commercial buildings. There's a number of thresholds available, but if you're using, say, more than $20,000 a year in natural gas, you would likely be able to find some sort of solution in that higher threshold program, because you'd be likely able to save the 1,200 tons of GHGs over the project life. If you're less than $20,000 a year of natural gas, maybe fit into the custom light program at some of the lower thresholds. Either way, it's about identifying what you need, and especially considering if there's any upcoming mechanical work, replacing rooftop units, replacing boilers, doing any changes. It's a great time to look at these programs. You make the application to CleanBC. If approved, go into the next step, which is an energy study. 50% of the cost of an energy study funded by CleanBC. And an energy study, again, includes reviewing the existing building. Where does the energy go? Where are you using energy? What kind of energy conservation measures could we come up with? How much would it cost to install a heat pump system instead of the business as usual? And making some recommendations as to what to pursue. And then the final step, of course, is after the energy study is submitted and approved, going into design and building it. Complete the detailed design, tender the work, get the new system installed, and receive the incentive from CleanBC in that range of $40 to $60 a ton. Again, if you're saving say 1,000 tons of CO2 over the project life, you could be looking at an incentive in the range of $40,000 to $60,000. Valuable programs, and that's it for me. We'd be happy to take any questions at this time.
Brandon, thank you to all the presenters, and just an apology to Blake, who I misnamed Blake Edwards and Blake Williams. My apologies for that, Blake. Q&A, I think possibly, well, first time we can defer if we think it's appropriate.
I think your audio is breaking up a little bit, but I'll paraphrase. I think what you were saying, which is if there are any questions, we'd be happy to take them. Maybe Kaylee, do you want to jump in and stick handle anything from the Q&A box, or?
Yeah, absolutely. So we have a couple questions here in the Q&A, and Andrew, I'm going to direct these to you. So we will start with, what is the downside of heat pumps? Is there always enough heat to heat buildings? And can you always cool buildings with heat pumps?
Yeah, I mean, so a heat pump doesn't generate heat, and that's an important thing to make sure I'm clear about. It moves heat. So a heat pump always has to be paired with an energy resource, and correctly sizing that energy resource is fundamental to determining if there's going to be enough heat, right? So if it's an air source heat pump, you're taking heat out of the atmosphere, out of the air. Yes, there's always enough heat as long as the equipment is right sized. Geoexchange system, similarly, you're pulling heat out of the boreholes, pulling heat out of the ground. For a correctly sized Geoexchange system, it should be designed to provide the correct amount of heat, that's needed. Of course, optimizing the sizing of a Geoexchange system is an important part of that exercise. And as far as providing cooling, I mean, yes, it's one of the advantages of heat pumps is that you provide both heating and cooling. It has a hot side and a cold side. If you can use the cold side for useful air conditioning purposes, that's a great benefit. Not always the case. A lot of the times, like a smaller building in a colder climate, colder part of BC, you don't necessarily need the air conditioning throughout the winter. So it's only the heating that's valuable. But it really starts to become valuable when you find those solutions that have advantage for use of both the heating energy produced and the cooling energy produced. The BCIT example is one such example where we did the data center cooling with the cold side of the heat pump, and the heat goes into the rest of the building to offset the district's steam purchases. So that's kind of a sweet spot for heat pumps, is when you can use both the heating and cooling effect.
Okay, so we will stay on the topic there of the heat pumps. Can buildings and homes be easily retrofitted to use heat pumps if they are currently using natural gas boilers and furnaces?
I can take that one again, and it can be easy, it can be difficult. I mean, a lot of it depends on the particulars of the site, and that's why we say the first step is to do an energy study and a walkthrough and look at the drawings and see what's possible. There are easy solutions like replacing an old gas-fired rooftop unit with a new one that uses a heat pump, but there are certainly cases where it can be more complicated and stuff. So it's really useful to get an engineer looking at these kind of projects and identifying like the easiest or the most effective place to insert a heat pump into an existing building.
Okay, great. With that, I'm going to move.
Sorry, go ahead. There's one question, if you can hear me on the chat as well. Maybe you going there.
Yes, I was going to move to that one, but John, would you like to take over now that you're back?
No, you carry on, Kaylee. You go ahead.
Perfect.
Thank you.
Okay, so we have someone here. We have Stephanie looking to build a commercial building for their small business. Blake, would you say there are any incentives for new builds? And if so, where should they go for more information to get the process started?
Yeah, myself. That would be the commercial new construction program. Provided, of course, the modeling shows that it will save up to, or at least 400 tons, it should be eligible for custom, commercial new construction.
Great. Well, am I audible now, Kaylee? I assume I am.
Yes.
Good, John.
Great, thank you. Thank you. Well, a big thanks to all our presenters for, I thought it was a great presentation. Big thank you to Kaylee for jumping in when my audio went off. Great job to you. And a big thanks to all of our audience for coming and making these presentations both vibrant, informative for us through the questions, and I hope valuable to you. We do a feedback screen that you can scan a QR code on your phone and give us feedback so we can continue to provide these presentations in line with your needs and the industry's aspirations. So with that, I will close. Again, a big thanks to everybody for being part of this presentation. And please stay tuned to pinchin.com as we continue our journey at helping inform our community of new developments. Have a good day, everybody. Thank you very much.